This conference will now be recorded.
Good afternoon, students. Wait for a few minutes. Let them students join here. Okay, students, we will start the class. Today we are going to discuss about two topics. One is short-term hydrothermal scheduling problem. Another one is feed governance system. This is the two important topics from the second unit. So I already told you that if you categorize that two parts from second unit, the first part is hydrothermal scheduling and second part is feed governing system. So you may get one question surely from these two parts. So from first part, 90%, that is maximum possibility of getting that. Explain about hydrothermal scheduling or decomposition method or long-term scheduling. In second part, you may get explain about feed governing system or else explain about turbine model, generator model, like that you will get. So just listen carefully. And the second part is completely derivation part of view. We have to make the block diagram based on that. What are the inputs and outputs transfer function? So shall we start the class now? So these are the two topics we are going to discuss in today's class. One is short-term hydrothermal scheduling problem and speed governing system. Now, what we are going to know in this topic, that is short-term hydro scheduling master, means so while scheduling that power generation with a short time period like 1 week or 1 month, what are the parameters we have to consider that, and what way it is better to scheduling in a short time. Generally, the most problem occurs in the short term is, so it is a keep on going to be scheduled entirely year. But in the case of long-term schedule, there is a once we have schedule in an entire year. So that is the problem between long-term and short-term. Now we'll see that what are the parameters are involving when scheduling the short-term hydrothermal scheduling. See, generally a system whose consists of a hydro plant and one steam plant, a simple timing program algorithm is enough. It means that suppose the only two plants are connected together for power generation, the dynamic programming algorithm is applied here. So what is meant by dynamic programming means, so based on our convenience, so we can change that whatever we require the parameters. So dynamic means instant changing parameters in the scheduling. So that is called as dynamic programming algorithm. Now we have the different steps involving while scheduling the short-term thermal scheduling. Let me see that one by one. First one is we have to the storage, the water storage X is quantized to levels. Suppose in this criteria we had to, the dam having that 1000 q6 capacity. Now we have to bring this 1000 q6 into the number of levels. That is lower head level, medium level, overhead level. So after that, based on the levels, we have to categorize that at So at level 1, how much of Q6 water is available? At level 2, at level 3. Based on this, we can generate the power. So that is the program done by first point. That is the water storage X is quantized to levels. So we have to split up. We have to divide the number of levels in the storage capacity. Next, the computation is started with the nth number of subintervals. So I already told you that if you want to make the schedule with 6 months, so that is the capital N is equal to 6 months. Now what we have to do is, so for obtaining that better performance, we have to schedule that with sub intervals. So we have to divide this interval to the sub intervals, like 1 month. One month means you can get the 6 intervals, or else 2 months maybe you will get the 3 intervals. Like that, you had to change that the total number of intervals to sub interval. That is the second step. That if the number of intervals is more, we can choose that. Suppose if it is 2, then we can choose two like that. If it is 6, that is better to take one like that, 1 month, 1 month. So for 1 month itself, we have to schedule and keep on going to increase that. Next one is corresponding to every quantized level of storage at the beginning of stage. Suppose if what day is over, now we have to schedule for the second day. What we have to do means, we have to check again what is the level of water after the first interval. So at that, so you have to proceed like this until that total intervals. Why? Because if you gather this information, then you can see that what is the power generation capacity done by the previous water level. Suppose for first day it needs 100 Q6 for power generation. While scheduling that second day, you can measure that it was reduced to 900. So from this you can say that, so for a particular amount of generation it needs 100 Q6. So that is the idea given by this point. And the value of Qn is the water discharge to the final specified level is calculated from the equation. So in this equation we can calculate that how much of water is discharging from the dam. How it means, suppose here we now after 1 day we have to scheduling for second day. What we have to do means, here this is the second day scheduling and this is the first day scheduling, and it means that what is the storage capacity on second day and on first day. Suppose if you take that first day capacity is 1000, after first day it reduces 100, so it becomes 900. Then you can get that what is the variations occur while first day and second day. So that is the difference we can get from here. And by using the that is the inflow, that is Jn is called as what is the inflow. So you can easily get that how much of inflow is coming to the dam. So how we can calculate that inflow in the dam? How we can measure water inflow into the dam? On which parameter? Right. So these are the 4 steps we are involving in the short-term scheduling. There are few more steps. Let me see that. See, the fifth point is the value of discharge which are not within the limits. We have to reject that. So suppose for generating 100 megawatts, we have to schedule that how much of water discharge will be available. If the discharge is within the, it is not within the limits, we have to eliminate that. We had again the scheduling of discharge. Next, second one is the cost corresponding to each QN is calculated. So we had to, so for our scheduling the 6 month, we had to calculate for every month, and also we have to check for first day what is the cost for generating a particular power for second day. So when we compare that both corresponding days, then we can see that how much of cost is weighted and how much cost to be saved. So that is the thing we have to proceed here, and the same procedure will be repeated for all the remaining intervals until the final interval is reached. So until we have to check that for six intervals for reaching that final interval. So this type of method is used for both long term and short term. But the problem is while scheduling these methods for long term, it will take that more data. Why? Because if you split up that 12 months in a sub intervals, you have to check that for one month. So you have to check for 12 months individually. So at that time we have to require that more data, and we have to work on this. So that is the problem. Remaining and all, we can go for the same procedure for both long term and short term hydrothermal scheduling. Now we go move on to the speed governing system. So before speed governing system, what is the need of speed governing system? So why we are using, why we are going to study that? Generally, our power system, there are different types of parameters are involving, right? So in that, to control the power system, the majorly we control voltage and frequency by controlling other parameters. Generally, in our power system, the voltage stability is the power stability is depends on that both voltage and frequency. And this voltage and frequency we can control by different parameters, different devices which are using the power system. Suppose here it shows that low frequency control and reactive voltage control. So how we can control the reactive power? By using the fax devices which are connected in the transmission line. Then we can control that what is the voltage level was we can control the voltage levels happen in the transmission system. And for efficient and secure, what is the need of low frequency and reactive power control means for efficiency. So for efficient and secure power system, how we can obtain these two means by maintaining the reliability. So what is mean the reliability? What is mean the reliability? Right. Uh, so I will tell you an example for reliability. If you observe the three-phase transmission line system, it is a double circuit, three-phase double circuit. What is the main intention of double circuit means? Suppose at the event of failure or repair of any one of the transmission line, we can use another transmission line as a backup. So without any interruption in the power supply, it makes that reliability of the transmission line. So that is called as reliability. It means that if there is no disturbance, it makes that reliability. Now next one is security. Stable operate is most economical way, better quality. So these are the different parameters we have to obtain. When we can obtain means by controlling the frequency and reactive power. Generally the frequency is in within the limits of 3%, that is total value. Generally the constant frequency value is 50 hertz, right? Sometimes it may be more than 3 or sometimes it may be less than 3. So that is called as tolerance value, and within the limits that is in the form of 3%. And voltage in terms of high voltage lines it is 5%, in low voltage lines 10%. So for maintaining this type of parameters, there is only one way: we have to control the frequency and voltage in the transmission line. Within the two, so when compared to the frequency and voltage, in that frequency is a global phenomenon. Why? Because if you take any system, single phase, three phase, high voltage, low voltage, whatever it may be, the frequency should be constant. So it is same at every node and other. It is, that's why it is called as global phenomena. But in the case of voltage, it is called as local phenomena. Why? Because one point and other point is different. Suppose if you take the three phase transmission line, the voltage level is different. If you take single phase, the voltage level is different. So how we can obtain this type of voltage and frequency base? The change of frequency and voltage affect normal operation of the system. If you want, if you not control these two parameters, that may affect on the load system. Okay, now, so that is the reason why our power system engineers are concentrating on how we can control the low frequency and reactive power control. For this purpose, we have to make that some arrangements in the power system. In the arrangements, one of the most important concept is speed governing system. And this speed governing system should be done in the generating stations. Let me see that how we can control the power from the generating station, how we can control the frequency, how we can control the voltage by using this method. Now, so there are two basic generation control loops. So if we take that generating station, it consists of it is a combination of different parameters, different devices like turbine, generator, whatever it may be. Now, in that, what we have to observe and what we have to control means the only two parameters, voltage and frequency. If you control these two parameters, then you can generate a real power as accurately. Now you see that what are the loops we have in the generating station. The first one is low frequency control, megawatt frequency control loop. So in that, so here AGC is automatic generator control. Okay na. So ante generator control ante dani యొక్క speed ni based on generation power ఎలా change చేసుకోవాలి. Next MVA. This MVA should be controlled by that automatic voltage regulator. Okay na. And this should be makes that MVR as a control and QV control loop. These are the two loops when we are using in the generation station for obtaining that voltage and frequency control. Next, let me see that what is frequency, load frequency control, and what are the different methods, different major parts involving in the low frequency control. Generally, in a power system, the load demand is continually changing, as you know that. Why? Because the load should not constant even a day itself. So it is keep on going to change hourly. Suppose if you take that industries and hospitals, it will work on the morning time. So evening time it will be shut down there. So it means that the load should not be constant, and based on the load demand, our power system has to be generated with respect to the load demand. And within a short time period, how we can control that that load changes means there is a we have different major parts we have, that is the three parts. One is speed governing system, rotating components, and load power system. And one more thing, in according to that power input, we have to based on the demand, the power input also change. So why? Because suppose if we see here, if our power demand is 100 megawatts, let me take that hydro power plant for generating 100 megawatts. The dam should open that 3 gates or 4 gates. Now, the load is reduced to 80 megawatts. What we have to do? We have to shut down that one of the gate. It means that based on the load demand, the power input, the input should also be changed, and that's why if the input output balance is not maintained, a change in frequency will occur. So we are not, if we are not maintaining that input output, that is input of fuel and output frequency output, then we can't able to maintain that frequency change in occur. Next, the control of frequency is achieved primarily through the speed governing mechanism, and this type of speed governing mechanism we can use and we can see in the thermal power plant. Why? Because this type of speed governing system we are using in the output input to the turbine. Why? Because see here, the turbine should be rotating by that. What is the steam is entering to the turbine blades. Suppose if the turbine should be rotating more, so why? Because the generator has the more demand load. What we have to do? We have to rotate the speed of the turbine will be more, and this can be achieved by using that the inflow of steam from the steam valve. సో ఎప్పుడైతే టర్బైన్ ఎక్కువ స్పీడ్ రొటేట్ అవ్వాలనుకున్నామో అప్పుడు ఏం చేయాలంటే స్టీమ్ అనేది ఎక్కువ ఇంజెక్ట్ చేయాలి. సో దట్ షుడ్ బి డన్ బై దిస్ స్పీడ్ గవర్నింగ్ మెకానిజం. ఓకేనా. ఆ వాల్ అనేది ఎంతలో ఓపెన్ అవ్వాలి, స్పీడ్ కి ఏ విధంగా చేంజ్ అవ్వాలి, అది వచ్చేసి స్పీడ్ గవర్నింగ్ సిస్టమ్ లో మనం తెలుసుకుంటాం. అండ్ we are making this speed governing system as a block diagram, and from this block diagram we can control that in different parameters. ఎందుకంటే in present the controlling action is completely computerized. So we have to give the what are the parameters and what are the requirements, and remaining the system should be working. Okay now in this low frequency control there are three major parts. One is speed governing system, and this governing system is for only how much of steam is input to the turbine. Next one is rotating component. So this is for turbine and generator. So where we are using that mechanical controlling, there we can use rotating component. Suppose if you want to suddenly reduce the speed, we have to use that braking mechanism on the generator. And next one is load and power system. So in load and power system, we can control the frequency by using that fax device. Then we can control. So these are the three major parts in the low frequency control system. Now you see that I will show you a video, so you can get clarity on this, how this speed governance system will be working. Just see this video, then only you can understand that what is the mechanism of speed governing system. See here, this is the different. This is the flybar system which is having in the speed governing system. Suppose based on this expansion of balls, if the expansion of balls, so if we expanding more, then the wall should be opening. So this is the wall of the water, and based on this position of this flyball, so this is called as flyball speed governing system. And based on this flyball governing, the wall should be opening. So let me check how it will be working. So when the expansion of balls, the wall should be closed. So you can see on the red marks, right? So that is the marks called as linkage mechanism. Linkage mechanism means if you control the one linkage mechanism, then it will automatically controlling by the all control mechanism. See here, based on the levels of balls, if it is rotating upwards, then the wall should be moves up, right? So based on the one mechanism should be linked up to the another mechanism, then the total system should be working by that one movement. So the same thing happening here also. So this is the structure of speed governing system. So it should be like this. And here it consists of four major parts. One is speed changer, second one is flyball speed governor, hydraulic amplifier, and linkage mechanism. By using these four parts, then we can control that what is the steam entered to the turbine. See here, if you observe this part, it is a part from here that steam will be entered to the turbine, and based on the flow of steam, we can control the turbine speed. Automatically we can control the generator, then we can control that what is the power generated from the generator. Now if you see this, I will show you that what are the devices including in this diagram. So this is called a speed changer, right? the speed in this year we can move upwards or downwards based on our speed requirement. Suppose if we require that more power, we have to rise and downwards. So it is completely opposite to the what we require. If we require more, we have to decrease this position. If we require less, we have to increase this position. See here, this is the speed changer, and this part is called as slide or speed governing system, and this is hydraulic amplifier, and it is a have in this amplifier there is a high pressure oil will be there, and it is the ABCD. So this is called as linkage mechanism. Now I will explain you how it will be working based on different conditions. Suppose if you need that more power, so what if you need the more power, what we have to do, we have to increase the generator speed, but the generator speed we can't able to control directly. So how we can control means we can control the generator speed indirectly from the turbine. So the turbine input is what, steam only, right? So based on the flowing of steam to the turbine, we can maintain the what is the speed we require from the turbine. Okay, now we'll see that if the generator having that more load, then the speed will be speed has to be increased. So for we want to speed increases, what we have to do means we have to bring this speed changer to the downwards. So we have to push back to the downwards. When this speed changes comes downwards, then the mechanism should be goes to the upwards. So it should be, so there is an opposite direction with involved in this mechanism. When the speed changer is moves downwards, the mechanism with respect to the C will goes to the upwards, then it should be comes to the downwards. So if you observe this mechanism, first and last should be same direction, after the middle linkage is opposite direction. So if based on these conditions, we can control that how much of steam has to be injected to the turbine. Now we will see that one by one, what is the functioning of speed changer, what is the function of governor. Let us see one by one, then only can understand that what is the involvement of these four devices in the speed governing system. Right. So let me see that what we need that speed governing system, and what are the fundamentals when we are applying that speed governing system. Generally, the power coming from the power station is real power, right? So here we have to control the real power by controlling the driving torque. Why? Because the power should be here we are converting mechanical energy to the electrical energy. So if you control the mechanical power, then we can control the electrical power. So the mechanical energy is completely belongs to that torque, that is a torque oriented. So if you control the torque, then we can control the speed. Automatically the power generated from the generator will be controlled. Now in this condition, the speed governor is the main part for controlling the speed frequency. Why? Because so speed governing is a combination of all term until that the valve of the steam. సో టర్బైన్ కి స్టీమ్ వచ్చే వాల్వ్ ఎలా వస్తుంది అనేది ఈ మొత్తం ఇట్ ఈస్ డన్ బై ద స్పీడ్ గవర్నింగ్ సిస్టమ్, అండ్ ఇట్ ఈస్ ఎ ప్రైమరీ టూల్ and main tool for controlling the load frequency in the system. And if it is not control the system, it is not control the frequency, it not control speed governing speed, then we can't able to maintain the load frequency as a controllable. Now by controlling the position of control valve or gate, so I already told you that based on that valve, the speed of the steam will be changed. If the valve should be open, mostly the steam should be fall on the turbine, then the turbine speed will be increased, right? So it is completely depends on that how much of steam will be falling on the turbine, and it is the pressure of the steam, and this can be achieved by that speed governing system. So these are the rules and these are the functioning of speed governing system in the thermal power plant. Now let me see that what are the devices, what are the parts including in that speed governing system. Right. So we will discuss that one by one devices that was including in the speed governing system. The first one is speed changer. So speed changer is only it has two ways. One is we can move upwards or downwards based on our requirement. So if you want to more power generation, then we have to bring the speed changer to downwards. If you want to limit that, if you want less amount of power generation, then we have to bring to move upwards. See here, the speed changer consists of a servo motor which can be operated manually or automatically for scheduling load at normal frequency. How the servo motor will functioning? If you observe that our toll gates, so the servo motor should move in an angle based rotation. Suppose 0 to 90 degrees, so it should be working as an angle based rotation. Same thing, if you observe that servo motor in the that is toll gates, it should move only two directions. One is open or closed. The same thing mechanism happening in the speed changer. Based on our power requirement, whether high or low, this type of mechanism is similar to the servo motor, and this should be controlled by manually or as well as automatically. If it is need to automatically, we have to couple that with respect to the servo motor. Then the servo motor bring the speed changer based on our angle. Now, by adjusting the set point, a desired load dispatch can be scheduled at nominal frequency. Based on the speed changer position, we can control the frequency of the power generation. So the entire mechanism is depends on that. What is the position of speed changer with respect to the load demand? So that is the thing we have to mention here. Next one is speed governor. So speed governor is we are using here is a flight of speed governor. So what is the function of speed governor means? It will governing that what is the linkage mechanism will be functioning in the system. It has the two bars. It should be like this. So what the function of this two bars means? It will controlling that what is the mechanism happening in the linkage mechanism. Now see here, this is the essential part or centrifugal flyball wheels driven directly or through gearing by the turbine shaft, and the mechanism provides upward and downwards vertical movements proportional to the change in speed. So this flyball, what it will do means it will make that upward and downward mechanism of a linkage mechanism. See, if you see in this diagram, this is the linkage mechanism. At one end we are using the speed changer, and here we are using that speed governor, and here hydro amplifier, and this is the wall. If you want to make this entire mechanism as a movable, then it should be happened by this flywall wheel. Again, based on this flyball wheel, then the mechanism should be moved upward and downwards based on our requirement. Right. Next part is hydraulic amplifier. And what is the main function of hydraulic amplifier in the speed governing system is this hydraulic amplifier controls that what is the mechanism happening in the linkage with the help of high pressure oil. So it has the high pressure oil, and it controls that unwanted mechanism happening in this linkage mechanism. See here, a very large mechanical forces are needed to operate the steam valve. Why? Because the steam valve should having the more pressure, so that's why that much of pressure of steam should be when enter to when fall on the turbine, then the turbine will rotate more speed. It means that you can assume that you can imagine that how much of pressure it has. So if you want to control that much of pressure, we have to have the more mechanical force acting on that, and this mechanical force was provided by this hydraulic amplifier. Why? Because the governor moments are transferred into high power forces via several voltages. Then how we can control the high power forces means by using hydraulic amplifier. Let me see how it will be happen. So this is the linkage mechanism. Here speed changer, here flyball wheel, and here we are using that hydraulic amplifier. And this hydraulic amplifier having that high pressure oil, and based on the high pressure oil, the volume of the steam should be changing. Let me see that how it will be changed. Right. See here, the wall. This is the wall that is connected to the steam to the turbine. And if we by moving this up and down drivers, then we can inject that high pressure steam to the turbine. And this movement is completely depends on the hydraulic amplifier. It means that how much of, suppose if the high pressure oil is injected here, what will happen? It the here the blocks is there, right? This blocks is moved in this direction, then it will be it will be fixed. So it cannot be moved up and down. So for fixed point, fixed position of control valve, we are using that high pressure amplifier here. So if the high pressure oil will get back, then the box should be comes in this direction. Then valve should be free. Then it moves to the upward direction. When it moves upward direction, then it is closed. See here, if the steam is closed and a valve closed avante, then it should be downwards. Okay now, when it is open, so this is the position of open and close. When it is open, it means upwards. When it is closed, it downwards. So based on the requirement of steam that was injected to the turbine, it should be have controlling by this hydraulic amplifier. Next, second one, linkage mechanism. So there are different. We have four linkages at the different positions that are A, B, C, D. Right. If you want to control that any mechanism, we can control directly from the any point A, B, C, D. So let me see how the A, B, C, D will be indicating here. See here, this is the point A, B, C, D. If you control any one of this point, you can easily control that E point. So this is the linkage points. So we have the 5 linkage points. Out of 5, by controlling the 4 points, we can control the E. So that is the controlling action by the linkage mechanism. Next, let me see that what is the working principle of speed governing system. So why we need that speed governing system is, as you know that a load increases, the speed of the turbine decreases. When the load, say, ఇప్పుడు ఎగ్జాంపుల్ చెప్పాలంటే మీ సైకిల్ అనేది ఇద్దరు వెళ్తే ఎంత స్పీడ్ వెళ్తుంది, సో ముగ్గురు కానీ నలుగురు కానీ వెళ్తే స్పీడ్ తగ్గుతుంది కదా. ఇట్ మీన్స్ దట్ when the load is increasing on this rotating parts, the speed will be reduced. So how we can maintain the constant speed means we have to give the more input to the turbine, then only it gains its speed. And when the load is increases, the speed of the turbine will be reduced. At that condition, by using the speed changer, we can use the command, then the fly ball moves outwards. So if the fly ball moves outward means if they are expanding, that the point B moves downwards. And point, so based on the point mechanism, we can increase the speed of the turbine. So when we move this type of mechanism and the valve should be opens and our gate increases the flow of steam to the turbine, thereby speed of the turbine increases and it maintains the constant frequency. So this is the working of speed governing system. Now in this concept, we are going to derive that what is the turbine model, what is the speed governing model, what is the generator model. Now, by using these three derivations and transfer functions, we are going to form one block diagram. And in that block diagram, it will easily show that what is the initial input, what is the output from the each block, and what is the input to the each block. And we can control. So, if the controlling action need, so from which point we can control that, and it will show like that. So this is the speed governing model we are going to discuss in tomorrow class. That is next class. So it is the most important derivation part from the second unit. So you may get different questions from this. So I will show you previous question papers. Then you can get clarity on this. How much of important it is. So just I will show you the previous question papers just for knowing. So what are the questions you will get from the second unit? See here, this is the question paper that was which is the paper that is R13 regulation, which is asked in 2017. So this is the derivation. This is derivation part. You may get a question in your external exam. Derive a small signal transfer function, model of speed governance system, and develop block diagram. So this is the that's why I already told that this is the most important question. So from this concept, we are going to make a one block diagram, and this block diagram consists of a Turpin model, generator model, and speed governing model. So by combining these three models, then we can make the block diagram. Next, I will show you one more question paper. Right. See here, this is the another paper. Explain the mathematical formulation of speed governing system. Yeah. So direct 10 marks you may get from this concept. So mathematical formulation in the sense based on the mechanism how we can make that equation from based on that. In suppose it has some five linkage mechanism, right? B, A, B, C, D. So in that the speed changer is connected to the point A. Now how we can control the point A mechanism is by using a speed changer. Next, the fly ball mechanism is connected to the point B. Now by using the point B connection, we can control that what is the how the fly ball speed will be working. Next, D. So here the D link is connected to the hydraulic amplifier, and by using this hydraulic amplifier mechanism, then we can control the speed of the linkage of the D, and here finally we can control the E link mechanism. So this mechanism should be done by using that mathematical modeling. So that is a mathematical formulation. So this is the other paper. Right. So here also we may see this question. Obtain the transfer function of a speed governance system. So we have to make that. So transfer function, right? If you the output by the input. So every model we have to make the design in the form of transfer function, and based on this we can make that block diagram. Okay, students. In next class we will go for modeling of speed governance system. It means that block diagram, how we can make the block diagram from each equation. So the derivation part. Okay, now, right. So this is about today's topic. Now I am going to end this class now.